So good morning, everybody. So I'm going to present the Sustainable IoT theme, which is represented by a working group on this, and Utz Rödig from UCC and Aidan Quinn from Tyndall and myself are the conveners of the group. So this is a kind of a presentation on behalf of the working group. So we were talking about sustainable IoT and what do we mean by this? What is sustainable IoT? So our view is that it's about long-term deployments without environmental impact. And as Matthias Hollig said, I mean, we are increasingly instrumenting our world to digitalize our world, and IoT is one of the key tools to do that. But if we deploy increasingly electronic and computing systems into our world, then what do we want? I mean, we want them to last for a long time, say 50 years, for example. And we just picked that number because it sounded long to us in terms of technology. We don't want to throw things away. You know, there's so much electronics that is being thrown away every year, and we want to avoid that. We want to have a low carbon footprint. So the way we power these devices needs to be efficient, and we want to use sustainable materials, so that things don't, you know, kind of toxins don't leak into the environment from these devices. So what does that mean in terms of requirements? What we want is we want these systems to be, these sustainable IoT systems to be adaptable to changing situations, changing environmental situation. And I'll talk a little bit about what we mean by that. That's quite a broad perspective. We want them to be adaptable to changing missions. We know our world doesn't stand still, you know, it changes all the time. And if we deploy something for 50 years, then we can be pretty sure that during the 50-year lifetime, you know, that these systems need to do something different to what they did when they were conceived, for example. So we need to have mechanisms to deal with those changing missions. And we want autonomous operation. So we want to be able to power these devices for a long period of time without having to send somebody around to change batteries, for example. But we also want to be able to manage them and ideally have this sort of distributed system approach that Matthias Hollig was talking about to make them more resilient. So what are the challenges in this? And so we were talking about billions of devices, and when we started to think about what should Connect 2 be a sustainable IoT be about, then we were talking about what about if we have in the future even up to 1 trillion devices, you know. So this is ever growing, almost exponentially growing number of these IoT devices that we deploy into our environment, that we carry on us, that we use. And so that's a challenge because, you know, kind of if we want to deal with these many devices, then how do we do that effectively? I said earlier, we don't want to throw things away. So we don't want electronic waste. We don't want to create these billions of devices that then end up in our environment and creating waste. We want to power them autonomously. And so that requires other powering mechanisms than charging up a battery, putting it in, and then hoping it'll last as long as possible. We want them to be secure and resilient, and you know, kind of Matthias Hollig was talking a lot about this, so I don't want to add to this. We want to be able to repurpose these devices, so that's a challenge. So how do we do that? And then another thing that we actually haven't spoken about at all is that at the moment we have lots and lots of different standards that are in terms of connectivity, in terms of software platforms, in terms of you know, analytics approaches, etc. And not all of them work actually very well together. And so we have this kind of zoo of IoT technologies that is also a threat to sustainability, because if we suddenly come up with something new that doesn't work with the old anymore, then how do we do that? How do we cope with it? You know, so that's another significant challenge for sustainable IoT. So if we look at the 3 pillars within the sustainable IoT theme that we defined is, so we want to create solutions for energy harvesting, storage, storage and power management to enable energy autonomous IoT devices. So we are going to look at how to do that effectively. we want to design sustainable low power IoT platforms that are based on reconfigurable, software defined, so programmable sensing, computation, and communications. And we want to develop novel security and resilience mechanisms for the IoT that go beyond sort of classical cryptography. It's not just about, you know, getting the data from a device maybe to the edge or the cloud and encrypt the information on that, but it's much more complicated than that, much more complex. So if we look at individual aspects around this, so one of the, just give you a flavor of some of the research that's currently going on, and we'll hear a lot more about that throughout the day through talks and posters. So energy sustainability at the edge. So the challenge here is to find these energy autonomous approaches. And so one of the approaches we are currently looking at within the group is to look at energy source and a package, so integrated energy harvesting and storage capability with power management circuitry. So to make the powering of the devices as efficient as possible. And so here there are ways of harvesting energy that we are looking at using thermoelectric approaches, using vibrational approaches, beyond sort of using sort of solar cells, for example. So having kind of an armory of different energy harvesting mechanisms that we can use depending on the application and use case of our IoT system. And then also, how do we need to also then think about how do we store that? So it's not only about harvesting, because we also need to store the energy, because the opportunity to harvest energy may not be continuous, it may be intermittent. So we need to capture that. And you know all of this debate from the renewable grid, for example, it's all, you know, around COP26 now. It's kind of pretty much in the press at the moment. And this is at a micro scale, a similar issue. So how do we store that? And so we're looking at micro batteries, for example, supercapacitors, etc. And then, as I said, is we want a minimal environmental footprint. So we are looking at sustainable materials and sensors for IoT. So one of the things we're looking at here is to deploy and reuse approaches, and deploy and dissolve approaches. So reusability of sensors, making sensors programmable, but then also looking at carbon-based sensing, for example. So if it's carbon-based, then it can decompose in the environment, for example. So reducing the environmental footprint through exploring how new or how different materials that perhaps haven't been used so far for this, how they can increase new, or how they can make new sensing devices. And then we were talking about how do we reconfigure this at a system and a network level, for example. So so this is an example that resonates also with the earlier talk. Is so if we want to make this secure and resilient, for example, then we want our system, we have these base stations, the sensors all over the place, and now suddenly we get an attacker, and the attacker might just do something very simple, jam the signal, the radio signal from the sensors to the gateway or base station, for example. So we want to be able now to respond to that, to reconfigure the system, to reconfigure connectivity, change the connectivity of individual devices, or change the communication stack, for example, using different protocols, different frequencies, for example, so devices tuned to a different frequency band that is not being jammed. And also perhaps use the system also to locate the jammer and reconfigure the system so that it actually, the capability moves away from the jammer. So these are all different ways of making IoT more sustainable. There's lots more going on. And so what we will listen to immediately after this talk, and then also after lunch, is a number of deeper dives. So the first one is looking at adapting to changing missions, so over-the-air updates. So Dr. Khaled Hassan from Danalto, one of our industry partners, and a former Connect PhD student will talk about this. We then hear from a current PhD student on battery depletion attacks. That means adapting to changes in the environment, where we now have attackers in the environment that try to do something. Then Aidan Quinn will talk about combustible materials for sustainable sensing. Again, how do we make this environmentally friendly. And finally, then Valeria Nico is going to talk about energy harvesting, so autonomous operation. And then we have lots of posters there that some of you might have seen them already. So please, if you're interested, have a look at them later on. Thank you very much.